In this example, I want to give you an introduction and a quick overview of some terms and various definitions that will be important that you will need to use in linear programming. So let's start with the definition of a linear equation. By definition, a linear equation can be described as ax plus by equals c. And again, it is an equation because it has the equal sign. In linear programming, we are going to be working with linear inequalities. And there are four symbols for inequalities. It can be the less than equal, greater than, or equal to symbols. So we would keep this same structure of ax plus by and our constant c, but we could use any of these four inequalities. So for example, if I use the less than, I'm saying that ax plus by is less than c. So in linear programming and in this set of exercises that we're going to be working with for this project, you will be taking linear inequalities and solving them as a system of equations. Some more terminology that is important for this unit is the type of inequality can tell me two pieces of information about the line that I'm going to graph. If you have the less than or greater than symbols, the line will be dashed. If you have less than, equal, or greater than or equal to, your line will be solid when you graph it. Now, the significance of the line being dashed or solid is really about my solution, and if the solution that I get when I solve the linear inequalities or the system of inequalities, if that is part of the solution. So when it is less than or greater than, you've probably worked with in prior courses the set of parentheses or an open circle, meaning that whatever the solution is, or whatever you get when you solve the inequality or when you solve that equation, that meant it is not part of your solution. If it's less than or equal to or greater than or equal to, that's the same thing as using brackets in our notation or having a closed circle, which means whatever you got when you solve the equation or solve the inequality, that means it is included in the solution. So not included in solution would be greater than or less than or greater than, parentheses, open circle. Included in the solution would include the less than or equal to, which is why it's included, greater than or equal to. The line will be solid. I would use brackets and close circle. So as we continue to do examples, you'll see the big picture of how all of this comes together. But I'd like to introduce this to you first before we get into the mechanics of the actual problems that you'll be doing in this project. Another definition that's important is the feasible region. In fact, I'm going to clean my screen and then I'm going to write some definitions. So give me 1 second to get my board cleaned off and then we'll continue with those terms. So the first term that I would like to review is called a feasible region. And that is what you're being asked to create with these systems of linear inequalities. And essentially what you're doing is you're going to graph each linear inequality and you're going to be looking for the corners or the region that is created by the intersection of the various lines that we're going to have. So I'm going to give you that definition though. So it is going to be an enclosed area. And we also can call that our bounded area. That is created by finding the overlap. And I'll talk more about that overlap term. of the shaded regions of multiple linear inequalities. So what that looks like is, let's say I have a system of 1, 2, 3 different lines that I've drawn. And if I perform all of my calculations and I solve all of my systems and I determine that this is a vertex, this is a vertex, this is a vertex, and this is a vertex, those 4 vertex points have created this an enclosed area or this bounded area that was found by the overlap. So when I shade the regions of each of my individual lines, it would create this shape with these 4 corner points, and that is what we would call the feasible region. And again, the system of linear inequalities and whether or not you're shading above the line, below the line, is going to tell us the direction that we're going to shade after we draw either those solid lines or those dashed lines, depending on the inequalities that we have. So again, it's so important to understand the purpose of the inequality. It tells me what type of line to draw, and it also tells me the direction that I'm going to shade. So I'm going to add this here again, so if it's greater than or greater than equal to, you will shade above the line. And if it's less than or equal to, you will shade below the line. So in this example that I've created here, that means whatever the 4 inequalities were that created this region, and I'm saying 4 because I'm also including this line y equals 0 because it's bounding it on the bottom here. The inequalities in the system, after shading in all 4 directions, it created this feasible region. So we're going to do an example, but I just wanted to point out these terms. So again, pointing to the circles where I've indicated, those are what we call our corner points, also known as the vertex. And the last term is intersection points. So the intersection points, these corner points, algebraically, we find these. You probably can answer this question. Where do you find the intersection points? That's when you will find those by solving, the system of equations. So we suggest that you take 2 inequalities at a time and you're going to set them up together and solve them. So for instance, if I wanted to find, let me change colors here. If I want to find this intersection point here that I've just drawn in green, that comes from this line and this line intersecting each other, right? So I would take the equation from those 2 lines and solve that system. Actually, let me correct myself, not equations, but inequalities. I would take these 2 inequalities and solve the system, and that point of intersection is what we're calling the intersection point, and that would be from solving the system. Now, quick review. How do we solve a system of equations? Algebraically, you have learned 2 methods: substitution or elimination. So we're going to use substitution or elimination to solve the system. So this concludes this video, and this would be just giving you a brief overview of what the terminology and a visual of what you will need. And in my next example, we are going to actually solve a problem completely all the way through with all the parts.